Hello everyone, my name is Ashish and welcome to Group Two's presentation on the findings and critiques of the Eglinton Crosstown LRT environmental analysis. I am joined by my peers Paris, Garthika and Kevin, who will introduce their thoughts shortly. To begin, here's a quick introduction on the project. This project is taken on by Metrolinx and the construction of it takes place across a 33-kilometer corridor that will connect Kennedy Station on the east end to Pearson Airport on the west end. This provides a potential greener alternative to existing transit options, which is highly favorable for modern projects. Analyzing the environmental aspects is paramount in ensuring a successful project delivery, since failure in doing so would result in decreased quality of life for surrounding neighborhoods, national repercussions due to an increase in national carbon footprint, or upsetting local ecosystems. Firstly, an air pollution study was conducted by 4Transit in which they thoroughly analyzed the changes in greenhouse gas emissions over the course of the project and what the levels would look like after its completion. This can be seen in figures 1 and 2 on the right. Overall, there was a 19% decrease in CO2 levels and a 42% decrease in NO2 levels. This was found to be the case as the existing diesel-operated buses that currently run on these routes would be replaced by greener, cleaner LRT systems that run on electricity. Next, it was briefly mentioned that there would be some emissions produced from the construction sites, but this was dismissed as it would only be temporary and thus not cause lasting damages. Some limitations to know from the study was that the number of cars was assumed to remain the same or decrease after implementing the LRT system. This may not be the case, however, since populations will continue to grow, which consequently would result in increased cars over the long-term period. Next, the report assumed that the project would be completed on time, which is no longer the case, as it has been delayed by 3 to 4 years. Thus, to ensure accurate air quality values, any further analysis should be conducted with delays in mind. Finally, the pollutants from the construction site should not be dismissed due to its temporary nature, as worker safety is paramount and should be taken very seriously.
It is very important to look at the energy source involved here. So the existing transportation method is buses, which is powered by diesel, which emits toxic gases. However, the LRT is significantly less harmful to the human health and the environment. Some of the limitations is that the report didn't look at the construction equipment emitting toxic gases. This is because the butterfly effect, small emissions combined, can be noticeable. Social impact is essential because it's in the definition of environment in Ontario. The LRT report does a good job at looking at heritage culture and takes a sympathetic approach and minimizes disruptions. Some of the limitations include it did not address the housing market, whether it's going to improve or decrease, and it does not look at how many people will be moving out or be bothered by the LRT noise afterwards. Also, the rent prices may go up, as seen on the graph on the right-hand side, when the public transportation is present.
I'm Gatia Ramanan. Improper management of excess soil can negatively affect ground or surface water quality and quantity in natural areas. In the LRT project, the soil report identified that most of the locations have various types of contaminations. The contaminated soil is not appropriate to reuse or under certain restrictions. To minimize the amount of excess soil, the excavation crew asked to excavate not exceeding the required level as per the drawings. Excess soil contamination in place causes a risk to human and ecological health. There are 250,000 cubic meter out of 2 million cubic meter soil reused and remain by moving to the housing plan area, Harrison land, operator land, and artificial construction land near the Humber River mouth. The hazardous materials contain soil disposed at the Dyson treatment plant for reuse. A better solution will dispose of the excess soil at the landfill. Temporary storage, which will be a solution to more problems. It improves time management and skips the project delay in activity excavation. However, there are some limitations to reuse the excess soil and transporting it. Reuse on site is not practical because of the sequencing of excavation and backfilling tasks. Also, soil quality should meet the existing soil condition. In addition to that, landfill locations are almost 40 kilometers away from the project site. The trucks travel far away against the bad weather and traffic. It takes more time for the one cycle travel. Also, transportation activities cannot conduct at night time because of dumping site will close at 6 p.m. and moving machinery vehicles noise disturb the residents. Temporary storage soil should protect from odor, dust, and contamination spread. Also, the contractor is responsible for leaking or dripping hazardous soil and wastewater and dragging mud or waste onto the public roadway when leaving the site. Thank you.
The project goes over many natural bodies of water and storm drainage systems, so it is important to manage water pollution. Some of the things that the assessment covered was establishing boundaries around these water bodies along 30 meters from the site. It identified areas that are most likely to suffer from erosion and change in sedimentation rates, and some mitigation measures were suggested, such as redirection of flow of water, retainment of vegetation, and regular scheduled inspections during and after construction. Some of the limitations that the assessment failed to deliver was that it lacked specification of area-specific mitigation strategies. It could have included a visual map to help show these areas that needed this specific instruction. They also did not consider scenarios that were negligible and offered no explanation as to why they were negligible. And it should always be done to plan for the unexpected, as these innovative solutions are a part of sustainable construction planning. Noise and vibration disturbances, these were measured based on criterias, and areas of high risk were identified, such as schools and high traffic areas. Um, the mitigations suggested followed bylaws and regulations set by the city and the province, and they did so by scheduled restrictions and acoustic barriers, not working during the night. And if there were scenarios where they do have to work in the night, they proactively gave a schedule where special exemptions would be required and notification to the public would be required. But some of the limitations of this assessment was that they adopted these criteria based on a 1990s project as opposed to a modern day project with similar conditions. The data used was very vague and there was no comparison or meaning, so it was very hard to understand what the data was showing us. And the conclusion lacked a variety of mitigation measures and only offered noise reducing barriers as the main solution. They could have used mapping or simulations to also help us with that. Well, in conclusion, careful planning and management for the construction phase of the project will determine whether environmental risks are explored and properly addressed. The impact assessment reports and identifies areas that require mitigation and areas that do not. It properly presented strategies and preventative measures where needed, but it was limited due to the lack of detail on how these measures will be effective and were not very specific. Although impact assessments are conducted early in the planning process, detail and impact management and reference to projects of similar conditions can result in successful and sustainable planning. This concludes our presentation. For more information, please check out our report as it goes into greater detail, and this is just a brief overview. Thank you.